Hi everyone, good morning. It's a pleasure to be here. And first and foremost, I would like to thank Sarah and Sean for inviting me because I've come here as a computer scientist. So it's always good to be in the company of like people who are in the actual domain, like where the groundwork is happening. The great thing. You had a good introduction to knowledge graphs from Yuri, which was really excellent introduction to what knowledge graphs are, how do they work, and stuff like that. So I'm going to talk a little bit further along that line on how knowledge graphs can be applied in the wind industry and cover some of the applications that could be possible with knowledge graphs. So yeah, what I'm going to cover is basically how we can use knowledge graphs as an interactive question answering mechanism for conversational AI in the wind industry. So that's the theme of this presentation. So wind energy, as you know, it's like growing rapidly in popularity. However, with that is growing the O&M costs and the challenges associated with it. It accounts for like 30% of total costs associated with O&M. And basically, a lot of work has been done in the past few years, maybe decade as well, in using SCADA data from wind turbine sensors, integrating it with AI models that can be trained with that data, with the historical failure logs, alarms, and stuff like that. However, as you know, it's still pretty black box, especially the neural nets, which can achieve high accuracy, but they are like very naive and they can kind of give you predictions without really telling you what's behind the reasoning or the decisions. So this lack of explainability, it really limits the trust and usability of these models by O&M engineers, technicians, people at the ground level, at the grassroots. Decision support, it needs to be actually human intelligible. It needs to be contextual. It needs to be actionable so that people can actually start to make use of things which are developed in academia, in the real world industry, right? So this is like the overall framework which I would like to talk about today. So you have like SCADA data, you would have an explainable AI model that would provide you like feature importances on what is actually causing a fault. Like you could use a decision tree, you could get use like that to get like feature importances of reasons behind a particular failure or a particular forecast. And then based on that, you can actually use a knowledge graph, as Yuri mentioned, which you can either create for your own domain specific application, or you could leverage something and build on top of it that is already existing in the domain. And unfortunately, there isn't like much that exists in the wind industry at the outset in terms of knowledge graphs for operations and maintenance. So that hopefully the motivation behind this presentation as well that can inspire like the people who are domain specialists to build their own knowledge graphs for O&M. So with the knowledge graph connected to the explainable AI model, you can use it for a plethora of applications, which can be like for explainable anomaly prediction, which can be for like O&M insights. You can query the knowledge graph and do some sort of reasoning, some sort of visualizations on top of it. So yeah, like the sky is the limit in terms of what you could do with the knowledge graph. Understanding knowledge graphs. So basically, what you heard of previously, it's a structured network of entities and their relationships. These relationships we can map out based on our own domain specific knowledge. So as a computer scientist, this is something that I did few years ago during my PhD. It was like during COVID basically, and I found something and I thought, okay, it's interesting to map out my own knowledge graph. So not really with domain knowledge as a specialist in the wind industry, but like it's my perspective on like as a proof of value or a proof of concept that what could be done. But I think like if you have to use something like this in real world, then you should really work together as a team, like between AI specialist plus between wind energy specialists to make this actually usable in a safety critical domain that is wind industry. Right. So you can actually have some sort of like functional group, like you have different categories of fault due to SCADA data, like gearbox, split systems, stuff like that. And then you could have an alarm, like there is a pitch heartbeat error, and then you could map out that relationships that this alarm affects that particular subcomponent, and then you could have like certain edges, certain nodes that map out that kind of relationship. And the good thing is there is a lot of work that has already been done in various domains, right? Like healthcare, finance, manufacturing, etc. But it's still like quite underutilized in the wind industry. So there is a lot of scope to like do knowledge sharing, learn from how people build knowledge graphs, like the best practices in building knowledge graphs in other industries, and then we can potentially reapply the same to the wind industry. So why the wind lags behind in knowledge graph adoption? So one of the major reasons is there is lack of real world integration with operational data like SCADA, alarms, maintenance logs, as you know, which are very confidential. So no one is willing to share the SCADA data. What faults occur in a wind turbine, things like that, maintenance logs, which makes it very difficult for people who are like computer scientists who want to do something like that to actually work on it without access to the data. And there is like no practical demonstration of use cases as much as it is there in other industries for O&M or decision support in wind. And it's very difficult for technicians to access these kind of like themes like knowledge graphs because it requires like specialized programming language queries that will like pull up different entities or nodes from the knowledge graph based on what you are trying to ask about. So that lack of natural language interaction, it comes as a big barrier to how SMEs and domain specialists, they can make use of something like that in practice. So what we did is we came across this kind of manual, which was from Skillwind project on technical description that was used to train wind turbine engineers and technicians. And then kind of I worked on that manual, created my own knowledge graph based on my best possible single person human interpretation on how the operations and maintenance strategies could be best organized. And then with that, what we get to is this. So it's like explainable AI for wind knowledge graph. So here you can see this was created with 537 nodes, 1059 relationships across 9 different types. It is multi-model, so you can have not just like text, you could have like numeric data, like the different thresholds of SCADA features that lead to anomalies. You could have like semantic relationships and stuff like that. And then you could have like, like what it looks like, you can see, right? The like some sort of a JSON or a dictionary kind of thing in which you can map out like this is a turbine, this is having different labels, like it's called study turbine, that's the location of the turbine, it's 7 megawatt, it's offshore. So you could create your own, like you could play with it and create your own sort of conceptual themes based on this knowledge graph. And then it's built with Neo4j, which is pretty much one of the most popular graph database management systems as of today. So it's very, very useful. It's open source as well, from what I know for doing these kind of things. So I would highly recommend you to look at Neo4j and you can kind of create your own knowledge graphs. It supports both like technical users and domain engineers because it has got something called like Cypher, which is the graph query language, which requires you some sort of programming knowledge. But Bloom is a natural language interface. So with Bloom, you can kind of type in natural language questions and it can query the relevant themes from the knowledge graph for you without having to know any sort of programming. So that is really good. Like it has that NLP interface as well. What the knowledge graphs can do, as you can see, you can put out like different fault events, different types of faults in the different subcomponents, what SCADA features affected, what are the corrective, preventive actions and things like that. What are the different things that are relevant to different kinds of anomalies in the wind turbine and a lot more, right? So that's like how you could actually build on this domain ontology. How the knowledge graph enables decision support. So basically, you can query with Cypher. If you are a domain, like a programmer, for example, you know how to write Cypher queries, which is used like that. As you see, match and preventive, that command, it pulls up the relevant preventive maintenance actions for a generator. So you can see like insightful visualizations. You can click on the different nodes and it will take you to more details on what is part of that node and things like that. And then you can map those to the different anomalies when you are predicting those with an AI model, right? So which I'll cover in the next slide, which makes it quite accessible to non-technical users such as technicians who might not be so familiar with programming and that kind of thing. So when you have like an explainable AI model, so be it a decision tree, be it some sort of neural network with attention mechanism, which can predict for you like what are the different things that are causing a particular fault in the wind turbine. So for example, in this SHAP plot. SHAP is a popular explainable AI library, and so is like Lime. There are a couple of those out there, but these two are most popular. So you can actually predict that these are the particular SCADA features that lead to the most kind of importance for the different types of faults in these 14 functional groups like yaw, pitch, gearbox, and whatever that kind of thing. And then you can actually get some sort of JSON, right? Because LLMs are quite good with JSON. So you can actually get some sort of JSON output that will tell you the feature contributions, that this is the anomaly detected, this is the feature importances for that anomaly. And then you can actually play with this and feed it to an LLM. And the LLM will be able to interpret that, and it can be very useful for creating like O&M reports and things like that. So from just a pure prediction, like binary prediction or a multi-class prediction that there is a fault or there is a fault in like gearbox, how do we get to something that is more concrete, that is more actionable? And that is where like the conversational AI comes into play. And that's where you can use these sorts of feature importances. You can use the knowledge graph and integrate it all together to make a like a holistic decision support system. Natural language question answering. So basically, the main idea behind this is that whenever you have some sort of like a human engineer that is asking a question in natural language and plain text, then with any model, like previously when there were no LLMs, you could actually train your own model. Like you could train your transformer to generate like these cipher queries, which is a formal language. So you can go from natural language to like formal language by training your own model. But the great thing now is with LLMs, they are very adept at generating code based on your questions. So for example, you might have heard, right? Like there was a joke about like if you go to ChatGPT, if you ask it to count number of R's in the word strawberry, then it would mess it up and it would give you like weird answers. But now, like if you kind of ask it that question, it will run the Python script in the backend that will actually count the number of R's in strawberry, and then it gives you the right answer. So that's the benefit of not relying on like just pure text, which would risk hallucinations, but actually converting your question into a formal language programming query, which will be used to retrieve the relevant answers from database or make some plots or make some calculations, which everyone is doing right now in the AI world. So that's like how you can convert these questions into cipher queries, and those cipher queries will pull up the relevant answers from your specific knowledge graph, which you have constructed for your domain. So basically, how do you ground your LLMs with domain-specific ontologies? So basically, the idea behind that would be to use any LLM, like you could use GPT, you could use Llama, you could use Claude. And then these days, what is very popular is the model context protocol, right? So the MCP, which enables you to create some sort of a client server interface, which helps you to connect your LLM to any sort of database, any sort of like it enables you to connect to different sort of files, like the JSON files I was showing you. It can connect to that. It can connect to your knowledge graph. So there is like lots of APIs that are currently being mentioned. Like it can connect to WhatsApp, and it could give you notification of a fault that occurs in your wind turbine. So it's like really cool area, this MCP that is growing and growing right now. So what you can actually do with this MCP is you can connect it to Neo4j. You can start your knowledge graph in the Neo4j database, and then you can ask the knowledge graph different questions by just using the LLM. So LLM is kind of your friend when it comes to querying the stuff from the knowledge graph. When you are not a programmer and you don't need technical expertise in coding and things like that, the LLM can code for you. It can ask the relevant questions from the knowledge graph for you. And that's the beauty, like you can integrate multiple systems, like you can integrate SAP work orders, you can integrate weather APIs and whatnot, and you can kind of make it like a really comprehensive decision support system, which I haven't seen to my best of knowledge, like something like that in the wind industry at the moment. So like a multi-agentic decision support system, you can have one agent for like power forecasting, one agent for like for fault prediction, and one for financial planning, modeling, and things like that. And when you break that all together, you can orchestrate it with the MCP protocol and connect it to different databases. So how does this work? So I'm giving an example of Claude, which is from Anthropic, right? The LLM from Anthropic. So with MCP, I can connect Claude as an LLM to different things in my knowledge graph. So Claude is able to read my Neo4j knowledge graph. It is able to type in these commands. You can see like find corrective actions and things like that. It can actually write these commands without any programming instructions from me. I can just ask it a simple questions that show me the corrective actions for a fault in gearbox. It writes that cipher query for me. And this is like just in 2 minutes, like I haven't even spent time in optimizing this or prompt engineering and anything, which is important if you want to deploy this in production, obviously. But like this is just to show you like how easy it is with MCP to connect to off-the-shelf knowledge graph, and then you can get something very cool, right? Like you can get like what are the different SCADA features that relate to gearbox faults and things like that, and it can connect to your SCADA data. It can show you what inference, what meanings it has, and things like that. Plus, it can also connect to your JSON files. Like if you are having an AI model that is making predictions of different sorts of faults, like I was showing you the JSON file with the feature importances and the fault predictions, it can connect to that and it can read like the latest JSON file, which is like the latest prediction for the fault in my AI model. And then you can create like an O&M report. So basically for 8th May, you can see like what kind of report it could create with a predicted fault timeline, health indicators, O&M actions, and things like that, all grounded on your domain specific data, all coming from your own knowledge graph without risking into the hallucinations that foundation models, right, like ChatGPT kind of are prone to, right? So that's like the importance of grounding your model on domain specific engineering and operational knowledge. And yeah, that's how it works. You can also get visualizations. So not just like a plain text output, which an LLM would give you, but you could also get like for your questions, you can get like these sort of graph visualizations, which shows you the relevant SCADA features, which shows you the relevant like maintenance actions and things like that. It's very useful if you want to validate what the LLM is telling in a quick glance. And yeah, that's like how you could make it very useful for engineers who have maybe very little time to, like read through a very big report, and they can just look at these simple intuitive visualizations and understand what's going on with my wind turbine, right? So in summary, I would say that this knowledge graph is a POC. It shows you that what can be done, what's the possibilities of using multimodal data within the wind industry. You can build on top of it. You can create your own knowledge graph in Neo4j, and you can connect it to any sort of explainable AI models that will enable like interactive question answering. This shows you like this plot, it shows you how complex the wind industry and AI is right now. It goes from everything from ANNs to, like traditional signal processing methods, hybrid mechanisms are also used. And yeah, like lots of different models are being used, decision trees, transformers, CNNs, and whatnot. So that's like a huge domain with huge possibilities. And what you don't see much here in this is knowledge graphs, right? That's a sad part to it, but I think hopefully it will inspire other people to kind of, like understand the value of knowledge graphs, the value it brings in terms of supporting data analytics and reasoning. And this is also scalable, right? So it's not just limited to wind industry. If you are in another domain like solar, or if you are in another kind of area, then you can actually use the same approach, use the same kind of features from the sensors. You can connect it to your own O&M manuals. You could create these sort of reasoning mechanisms. And then future work can focus on encouraging like SMEs and to build their own graphs and ground their AI models on domain specific knowledge. And of course, like what we don't have right now is unified industry standards, right? So like everyone is building graphs in their own way. But as you saw with the today's and yesterday's workshop, that we are now having some work that's going on in the in our IEA WindTask, right? In which we are trying to propose like a consistent way of best practices for developing your own knowledge graphs. So that's going to be hopefully, yeah, helpful in this area as well. And with that, thank you very much and open for any questions you have.
Thank you very much. We now have 10 minutes for questions before we start the panel discussion. So, yes, we have in the room.
Very good presentation. How does the computational time of creating a knowledge graph compares to fine-tuning one of those large language models using the same data set?
Yes, no, that's a good question. So in terms of computational time, I would say that only time you need is to kind of build your knowledge graph. That's the most, like building your own knowledge graph, that's the most time consuming part to it. It's like nothing, like it's very, very quick in terms of like once you have your knowledge graph ready, then it's very quick. You don't need to fine tune or you don't need to do anything. You can just connect it like outright to any LLM and it will just work off the shelf. But with fine tuning, it can be quite expensive because you would have to kind of arrange your data in a specific format as well. And you would have to kind of, like validate it as well, which is very hard to do, right? Like if you are fine tuning a model and you are getting some sort of output from it, then you can't really know that is it like actually hallucinating or making stuff up. But with the knowledge graph, because it is writing a specific query for you, you can actually know that, okay, it's pulling up from that part of my logic graph for this particular fault. And then I can actually know, like, is this correct or not? I mean, even if it gives a false answer, then you will know it's still from your own data, like without hallucinating. So yeah.
I was pretty excited about the multimodal aspects that you talked about. Could you expand on that a little bit? I mean, are you able to combine, say, sensors with vibration time series with SCADA alarm and wind speed scaler? Like, how? Tell us a little more about the multimodal.
Yes, yes. So basically, like in terms of multimodal, if you have like different nodes with like there is a fault in a blade, for example, so I can actually add images to my different nodes as different labels in the knowledge graph. So I can actually incorporate that, and whenever there is a particular fault that is happening, I can use that as additional context for the LLM. So that images that I have stored in my knowledge graph, it can go in as additional context, and same goes for like SCADA values, right? So if there is like a particular fault in a gearbox, and then I have in my knowledge graph, like these are the thresholds for the SCADA features for the gearbox, then it can actually look into those numbers. So I'm not just giving like the organization or the, like the branching kind of thing to the LLM, but I'm also giving it like the precise granular details, like, okay, this is how a typical blade fault looks like, which can lead to these kind of consequences. And then you can like compare your current image maybe of the blade captured from a drone to the image that is stored in the knowledge graph, and the LLM can process it to understand a bit more.
So for all the different modalities you're including, you have to apply those labels when you're building out the knowledge graph.
Exactly. Yeah, that's right.
Can I ask a quick question, please?
I think Chris, let's do Chris and then Uzo. Hey, Alexander.
Well, go before me this time. I got to go first last time.
Okay, thanks for that. Thanks for this presentation. It's really an eye-opener and tries to reinforce the knowledge I have on AI-driven solutions within wind infrastructure. My question has to do with this, and bear in mind that I'm really a novice in all of this, and if what I'm saying is rubbish, then just say, so you're talking rubbish. So what's the difference between using an LLM AI solution versus actually building using machine learning or deep learning, creating deep learning modules that consumes, for instance, SCADA data or whatever data, time series, whatever data you have within your organization for your wind farms, and then crunching that data to produce an output that relates to maybe an anomaly or a defect and all that. what's the difference? Are we talking about the same thing, or are they two different things? Using the LLM to look at the knowledge you have within the organization versus using machine learning or deep learning to create modules that are specific to crunching your actual data and producing outputs that directs you to reschedule, to schedule resources to go and fix stuff. What are your thoughts, please?
Yeah, no, that's a good question. So yeah, I think the first one, right, the predictive model. So like having your own data and having your own predictive models, that's absolutely still required. Like these models would serve as, like you would want to train your own models for predicting some sort of forecast or predicting a fault and things like that. So that won't go away. But where we need the LLMs is for the conversational layer, like so basically where the LLMs is actually coming in handy is it's getting the context from all of these models that you existing models that you had. So for example, you had a power forecasting model that is forecasting like doing a short-term power forecast, and you can give that prediction to the LLM as additional context. Plus, you can also give something from your knowledge graph that okay, these are the different like weather conditions that can affect the wind turbine power output and things like that from your own for your own particular wind turbine, and then it can combine all that knowledge. So basically it orchestrates all that knowledge and uses that simultaneously in parallel to kind of give you a O&M report or a summary and answers to your
Yes.
natural language questions. So yeah, I mean in a nutshell, like basically all those predictive models that you train with your own
It'll come back in a second.
yeah, so basically
You don't have to do these things.
yeah, the predictive models that will still stay, and then you will be able to give that knowledge to your LLM and have that, like chatbot kind of interface. So that's where it comes in
Yes.
handy.
Lovely. Thank you so much for this. This is new knowledge, new information for me. I appreciate it. Thank you.
Thank you.
Is there one final question before we do the panel discussion?
So the knowledge graph dynamically update themselves.
What do you mean, like in terms of
So it's what the question asked by Buzo is kind of you get the information
Mhm.
over time, right? It's changing.
yeah, so you
So
will have
do
to
you
like,
update the knowledge graphs correspondingly based on those information?
you will have to like do that. Like someone would have to go in and like
It's a bank.
add a new node or edit an existing node and things like that, which is very very straightforward as well. And the great thing is again, I don't need like specialist programming language for knowledge for that. So I can just ask a natural language prompt and tell it, okay, please add this new fault event to the knowledge graph, and then it will just in the backend it would execute that cipher query and it can update the knowledge graph. But yeah, like the good thing is if you do that periodically, then you can kind of have the LLM also stay up to date, right? So the LLM will be kind of having that pipeline to your knowledge graph. So as long as the knowledge graph is up to date, the LLM's responses would be trustworthy. So that's super important.
I think Chris has.
Just to quickly add, that inserting manually is when it comes to like actual knowledge, when we are talking about like information that comes from sensors, it just like any other database, it can be just pushed into a database. It's just information coming from sensors directly without any human intervention, as long as the structure is already given. It can be automated. Yeah.
Thank you.
Thank you very much. Now we're going to move to the panel discussion. So can I ask the panelists to come forward? Yuri, can you just help me with the camera? So the camera should be pointing at the people. I actually miscounted because Gareth is online, and I can see I've spotlighted you, Gareth. So in a second, everyone's going to see your smiling face. You want to quickly speak so we can check that we can hear you?
Hi, everyone.
Hello, great. I'm just going to quickly reorganize something. Going to get the presentation visible. We're not seeing our face anymore because we're just going to quickly show the presentation. Do the speakers want to come forward and sit down? Did I turn the recording off? I wanted to, but did I actually do it? I didn't. Okay, bye bye recording.